So, have you ever stopped to think about what it would take to upgrade the entire internet? I'm not talking about just an app on your phone, but the fundamental rules that everything, and I mean everything, runs on. It's a massive challenge, kind of like trying to change the engine of a jumbo jet while it's in mid flight with billions of us on board. And that brings us to the big question, right? Why is the internet so hard to upgrade? I mean, we get software updates all the time, but the core of the web has been running on the same tech for decades. So today, we're going to dive into the huge battle to make the web faster and the surprisingly powerful forces that are, well, fighting back. All right, let's get into it. And to do that, you need to meet the main character of the internet's stories so far. It's a protocol called TCP, and it has been the reliable, totally unsung workhorse for pretty much everything we do online. And when I say it's been around for a while, I really, really mean it. The first blueprint for it was published way back in 1974. To put that into perspective, TCP is older than the World Wide Web itself. And yet when YouTube launched in 2005, and even when TikTok completely took over the world in 2016, they were both built on this exact same foundation. That is some serious staying power. So what exactly is TCP? It stands for Transmission Control Protocol, and its one big job in life is to be incredibly reliable. When you send or get data, an email, a photo, a video, TCP makes sure every single little piece, every packet, arrives in the correct order. It's been so good at this, so dependable, that it's absolutely earned its title as the workhorse of the internet. But even the best workhorse eventually shows its age. And that amazing reliability, it comes at a price. For one, it has a slow start. It needs this back and forth handshake with the server before any data can actually be sent. And worse, it's got this huge problem called head-of-line blocking. Just imagine a single lost data packet is like one car getting a flat tire and blocking every single lane of the highway. Yeah, nothing else gets through until that one piece is found and fixed. And on the super busy, complex web of today, those little delays, they really start to add up. So engineers went back to the drawing board to design a modern upgrade, one built specifically to fix these exact problems. And it's called QUIC. QUIC stands for Quick UDP Internet Connections, and the whole goal is right there in the name, speed. It's a brand new protocol designed to take the speed of one system, called UDP, and combine it with the reliability of TCP, all while building security right into its DNA from the start. And QUIC just demolishes TCP's weaknesses. That slow handshake, QUIC squishes it into a single step. Head-of-line blocking? Poof, gone. With QUIC, every stream of data gets its own lane on that highway, so one lost packet doesn't cause a traffic jam for everybody else. It's even got this killer feature called connection migration. That's what lets you walk out of your house and switch from Wi-Fi to cellular without your video call dropping. Oh, and it's always encrypted, which is a huge deal. So let's recap. QUIC is faster, it's more efficient, it's more secure. The choice seems obvious, right? Time to switch. Well, this is where we crash headfirst into the internet's own, very powerful defense mechanism. I mean, if QUIC is so clearly better, why isn't the entire internet using it right now? This is the core of our story. And the answer is a fascinating phenomenon that developers have nicknamed the internet's immune system. The technical term for it is network ossification. Basically, for decades, all the gear that stitches the internet together, firewalls, routers, all sorts of things called middle boxes, they've all been programmed to expect just two things, TCP or UDP traffic. So when they see a packet with a new protocol they don't recognize, they treat it like a foreign invader, and they just drop it. The internet literally rejects the upgrade. So how on earth do you get around that? Well, the engineers behind QUIC came up with this absolutely brilliant workaround. They basically disguised QUIC to look like something the firewalls already know and trust. See, QUIC is built to run on top of UDP, so to a firewall, it just looks like regular old UDP traffic. This lets the brand new protocol sneak right past the internet's immune system. It's pretty genius. So, problem solved, right? Well, not quite. Sneaking past the firewall is only step one. Your browser still needs a way to know that this secret, faster path is even available. And this is where things get really interesting, because the two biggest browsers, Chrome and Safari, came up with two totally different strategies. Okay, so you have Chrome on one side and Safari on the other. Chrome's method is pretty pragmatic. The first time you visit a site, you connect with old-school TCP. But the server replies with a special note that basically says, hey, for next time, there's a faster way. Use QUIC. It's like finding out about a shortcut after you've already made the trip once. Safari, though, tried to be even smarter. It asks the DNS, the Internet's address book, before it even connects, hey, is there a quick shortcut available for this address? That way, it could be faster on the very first visit. So, with all this clever maneuvering happening behind the scenes, you have to ask, does any of it actually make a difference? Is QUIC really faster out there in the real world? Oh yeah, the data is pretty clear, especially for heavy-duty stuff. In a study on live streaming, a full 70% of connections using QUIC got to a really high-quality 5 megabits per second or more. For the older protocol, only 56% made it. In plain English, that means much better quality video and way less of that dreaded buffering wheel. Okay, but here's where a real mystery starts to unfold. When researchers at APNIC Labs looked at the data, they found that on the very first visit to a website, only about 15 to 20% of connections were actually using QUIC. And that seems kind of low for this supposedly amazing new protocol. But then, look at this. For every other connection to that same site, the number jumps to a massive 70%. You're seeing Chrome's learn the shortcut method in action right there. But it also makes you wonder about Safari's Ask First method. Why isn't it working more often? And that question leads us to this jaw-dropping data. When APNIC Labs broke down the failures by browser, they found that Chrome fails to connect with QUIC about 11% of the time. Okay, not perfect, but not bad. But Safari fails a shocking 45% of the time. What is going on? So what is the deal here? Is Safari's implementation just broken? Did Apple build a theoretically faster system that, in the real world, is a massive failure? The answer, it turns out, is no. It's the Internet's immune system striking again, just in a different place. This time, it's called DNS ossification. Remember how Safari asks the DNS for a special record? Well, that record type is brand new, and a lot of the DNS servers out there are old and they've never heard of it. So, just like the firewalls from before, they see this weird request they don't understand and they just drop it. Safari never gets an answer, so it just assumes QUIC isn't an option and falls back to slow, old TCP. This whole saga, from the network middle boxes to these old DNS servers, it all points to this fundamental challenge for the modern internet. It's something you could call the permissionless innovation paradox. As the researchers at APNIC Labs put it so well, the whole idea of the internet was to enable permissionless innovation, this beautiful concept that anyone could build something new without having to ask for anyone's approval. But the very success and unbelievable scale of that environment has now created this powerful inertia, this ossification, that makes real fundamental innovation incredibly hard. And that leaves us with one last big question to think about. Is the internet a victim of its own success? Its massive, planet-spanning deployment is both its greatest strength and now its biggest obstacle to progress. The whole battle over QUIC shows us that upgrading the internet isn't just a technical problem anymore. It's a fight against the inertia of the very world we've all built.